Hi everyone. I'm delighted to tell you that my PhD student Herman Montoya-Sanhueza has just published another paper from his PhD research, and this time the work is on Bethiagus. And Herman is here to tell us a little bit about this work.
Thank you, Nusha. Yes, well, this species is very interesting. It's a subterranean species from Africa, especially from the Western Cape of South Africa, and is one of the largest subterranean species, mammal species in the world. It can weigh up to 2 kilograms, and they have a very specific way of digging, which is by using their claws, long claws. And in this paper, we did included several methodologies to understand the process of limb bone growth in this species.
When we look at your results, it's evident that you worked on ontogenetic growth of Bethiagus. But what can you tell us about the results that you found?
Well, the results are very interesting. We have several kind of results, and one of the most interesting is how the shape of the bones change between juveniles, subadults, and adults. And actually, we can see that when they are juveniles, they have very robust bones. So the bones in external shape are very thick, but when you see the internal structure, the cortical wall is very thin. But when they are adults, they have elongated bones, more slender, but in internal structure, they are very thick. And we think that this is an adaptation for digging behavior and to increase the resistance for torsion or bending when they are digging.
That's fascinating. So, Herman, when you look at these juveniles and adults, you can clearly see how the morphology actually changes. But what happens at the even earlier stages? I mean, what can you say about that?
Yes, we have the luck to find some specimens, early specimens, so perinatal age, and we found that when you analyze the morphology of, for example, the sister species, which is Batyergus geneta, you can see that the development of the deltoid process or the extension of the elbow is already quite highly developed. Yeah? And if we compare this morphology with other subterranean rodents from South America, for example, we can see that the African mole rats, they have a more advanced stage of development in these features.
And so what can you say? I mean, what is the implication of the study?
So the implications, there are several implications, but one of the most important is that when you analyze ontogeny, you can track and you can determine different growth patterns in a species, and you can see if these species are adapted in a similar way or not to specific lifestyles. For example, digging behavior, it can be developed in different ways, and that is a very interesting comparative result from our study.
So, Herman, we see these very interesting developmental patterns in modern taxa, and it's wonderful that you can study this and you can document how the phenotype changes during ontogeny. But, as a paleobiologist, I have to ask this question. What are the implications of your research for paleobiology?
Okay, well, we actually know that, for example, non-mammalian therapsids and early mammals, they were using subterranean niches to live. That is evidenced by different fossils that they were found in burrows. But now we can use this information to understand if the biology of the growth patterns were similar between modern mammals and these fossils.
Wow. I think that's really very, very cool. And I guess it's a question of watch this space because I am quite sure that this study will actually give impetus for a lot more research. So thank you very much, Herman. Congratulations again.
Thank you very much, Anusha.
And I urge all of you to look out for the paper in Developmental Dynamics.